Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj. So with this video I am going to start with the discussion of statistical physics. It is part of module 5 computer science and allied branch engineering physics syllabus. Already I have discussed physics of animation. It also comes in this module 5 only. So many students requested me to take up this particular topic, hence I decided. So here is the video. Please as usual share your comments. Please give me your feedback so that I can improvise in subsequent videos. Okay, so when you see this word statistics, first of all, something will come to our mind. We feel that statistics, what role the statistics has got in physics? Actually, many people think that statistics is the part of commerce or economics or applied mathematics or business administration. Strictly speaking, it is not so. It is part of everything, not necessarily administration, not necessarily commerce, or not necessarily applied mathematics. You can see the role of statistics in science, engineering, medicine, agriculture, politics. Everywhere you have statistics. Okay. What is statistics then? In a broader sense, I can say statistics is a branch of applied mathematics which deals with collection of data, organizing the data, analyzing the data, presentation of the data, and then interpretation of the data. Okay, I repeat, collection. It starts with collection, organization, analyzing, presentation, and then interpretation of the collected data. So this is the broader way of defining the statistics. I give you one simple example so that you can understand it in a better manner. Always when we see some examples, we can understand the concepts in a easier manner and convincing manner. Okay, one example. You want to analyze the tiger population. One task is given to you to find a tiger population in a particular forest area. Let us say in Karnataka, how many tigers are there? So what to do? First you identify the forest area where actually you are going to do the survey or where you are going to do the data collection. Well, I identify Bandipur and nearby area. So that forest area is rich in the sense it is well known for tiger population. Okay, so there you go and collect the data. So directly you cannot go and count the tigers. It is not that simple. Okay, I am giving you what are all the procedures to be adopted to find the number of tigers right now in that area. Okay, in 1 year, that is it, let us say 22 to 23, how many tigers are there? Tiger population you are counting. Okay, so what are all the factors? What are all the data you are supposed to collect? What are all the data you are supposed to collect? Can you make a list? No? Yeah, you know what are all the data you have to collect. First of all, identify the forest area, that is one data, whether it is 1000 hectare or 2000 or 3000 square kilometer, something like that. So you have to find out, identify the area from where to where you are doing the census. That is number one. Next thing, in that forest area, what is the grassland? Sir, why grassland I need? I am there to count the tigers. Whether tiger is going to eat grass? No, that's what I am telling you. You should have thorough knowledge about the work assigned to you. You are there to count the tigers. Tigers normally live where there is enough grass. What is the connection between grass and tiger? Tiger never eat grass, but the tiger's prey is deer, jinke. So deer food is grass. Where you have enough grass, there will be enough deers, and when there are enough deers, there will be tiger. So you have to have this knowledge and measure the area, grassland area. Then you count the number of deers and find the population of the deers, and then also you find out the number of monkeys in that region. Sir, what sir? We started with tiger. Why monkey is coming into the picture? Okay, you said deer is the prey for tiger. Okay, I accept. And grass is the food for deer. Okay, that I will consider. But what monkey is doing here? Dear students, you might not be knowing this, no? Monkeys and deers are very good friends. You know, monkeys normally they are in the top part of the tree, upper branches they will be sitting, and deers will be in the foot of the tree, and monkeys will see the tiger which is coming somewhere about 500 meter or 1 kilometer, they can make out. Okay, so immediately monkey will give the precaution to the deer. Do you know this fact? So monkeys will start shouting, they break up the branches, they pluck the leaves and drop it to the drop it to the ground so the deer can get the signal about the forthcoming danger. So monkeys will shout, that itself is a signal for deer. Monkey ಕೂಗುತ್ತೆ, ಜಿಂಕೆಗೆ ಗೊತ್ತಾಗುತ್ತೆ nearby there is tiger anta. So then the deer will take the precaution. You know this point. So monkeys and deers are very, very good friends. So monkey will come to the rescue of deer. It will give precaution, much earlier precaution it will give, and it is very not easy to make out the tiger movement. Tiger is such a clever and well trained animal. It can attack without giving even a small clue also. So but monkeys can make out. So see, I started with statistics, I went somewhere else. Don't worry, I will connect it. So my intention is to count the tigers. So for that, what are all the data I have to collect? First of all, I have to find the area. Next I have to see how much of the forest area is covered with grass. Then in that forest area, how many deers are there, how many monkeys are there, okay, how much of human interference is there, and how many poachers are there, how many people are disturbing this atmosphere in the forest. All these things you have to consider. In addition to that, you also find out how many lakes are there. Water is very important. Then you have to identify the footprints of the tiger. Okay, so all these things you arrange, organize, then you come out with some observation and then give the result. If there are deers, then it is clear indication that there are tigers. If there are no deers, there are no tigers. Understood? Okay, and if there is enough grassland, definitely there will be tigers. Like this we have to organize. And also you compare this data with previous year data or 10-year-old data, or you keep it ready so that the next after 10 years somebody will come and compare this data. So they will say in 2023 there was 5,000 square kilometer area covered with grass. Therefore, there were 2,000 tigers. Now the grassland has been reduced. That's why tiger population also reduced. Like this, they will come to the conclusion. Did you understand? So this is what is called statistics. Statistics is nothing but collection of data. While collecting, you have to collect it systematically. I would rather say you collect it scientifically. Okay. So collect it scientifically, organize the data, analyze the data, and then come out with conclusion and then give the report. So this is statistics. Okay, one more example I give you. In your school there are about say 5,000 students, right? Now I want to see the performance of the students every year. So what I have to do? Collect their marks. Okay, take the report card, or you go to office, take the report, first standard, how many students are there, how many of them have scored 90%, 80%, 70%, like this, and then you organize it. It is also statistics only. So this way statistics plays major role. For example, industry distribution. In India, where do you find more industries? What are the reasons for the industries? Okay, in Karnataka only, where are the industries? Or in Karnataka, which industry is more popular? It is software industry. Why it is more? In which area there are more software companies? All these things. Okay, so it is nothing but statistical survey only. Well, this is general sense, broader sense. Very recently we had COVID, and in COVID the statistics worked beautifully, and in fact that statistical analysis of COVID cases helped a lot to control COVID well within time, well within stipulated time, and very quickly also. So statistics is a very wonderful and powerful tool, I tell you, dear students. So statistics is not a part of mathematics alone or business administration alone. It is there even in physics also. In physics, how it is, I tell you. See, in physics, we have statistics. Initially, we had statistics initially in mechanics. So we called it as statistical mechanics. But now we have statistics in each and every branch of physics. So therefore, we call it as statistical physics. In olden days, it was called as statistical mechanics. Now we have statistical physics. So in physics, what we do, we try to explain the macroscopic properties of the matter, bulk matter, with the help of laws governing the atom's motion, atomic movement. So first of all, we look at the atomic movement. If possible, electrons movement, there you try to analyze and then you generalize and apply it to the bulk material. Best example is kinetic theory of gases, which you studied in PUC, kinetic theory of gases. What is this kinetic theory? Recall, kinetic theory of gases deals with the gas molecules motion with the help of movement of the molecules, movement of the atoms. See, we are at the atomic level. With the help of number of atoms moving randomly within the given container, right? We try to answer temperature of the gas, kinetic energy or internal energy of the gas, pressure exerted by the gas on the container. If this is a container, how much pressure is exerted on the walls by the gas molecules in terms of their velocity, that is called RMS velocity. So there we consider statistics only. So number of molecules moving in a given direction, now number of molecules colliding in a particular interval of time, all these things are considered to arrive at solid decision about the temperature of the gas, variation of the temperature with respect to pressure, variation of the internal energy with respect to work done. All these things we can explain with the help of statistical physics. Okay, and not only that, we can use the statistics for the distribution of energy levels. Please recall quantum free electron theory. There your teacher might have explained, in a container we have number of energy levels. These energy levels are discrete. These energy levels are discrete. How many energy levels are there in a particular interval of level E and E plus delta E? So from here to here, how many energy levels are there? That we can calculate. The distribution of energy levels we can calculate with the help of statistics only. So there comes statistical physics to our support. Not only distribution of energy levels, see, when you drop electrons into this container, the electrons are going to be distributed in the energy levels. So how these electrons going to distribute, that also we can identify, we can calculate with the help of statistical physics. Like you enter your college campus, let us say today morning, gate open, 2000 students enter in, and they all are not going to sit in the same classroom, all of them are not going to the same floor, they get distributed. How they distribute? Based on various factors they distribute. Number one, they distribute based upon their semesters. Number two, they distribute based upon their timetable. Number three, they distribute according to their open elective or some other criteria, like today I have physics lab morning 8 to 10, some other students they have chemistry lab, some other students they have project seminar, like that they distribute. So the distribution is also done with the help of statistical physics. So statistical physics helps us to identify the number of energy levels. Not only that, with the help of statistics we can explain superconductivity, magnetism, right, and then noise in electronics devices, hissing noise will come, that is called disturbance, signal propagation. There also make use of statistics. Like this, so many examples are there. So best example at your level is kinetic theory of gases. Okay na? I hope you got the importance of statistics, why it is not that important. Till now you were under the impression that statistics is only for people who study commerce, where they deal with mean, median, standard deviation, etc., etc. No, it is not so. Even we people also need statistics. Okay, now coming to next heading, types in statistics. There are two types, namely descriptive statistics and inferential statistics. What is this descriptive and inferential? Now you know statistics is nothing but collection of data, organizing the data, analyzing the data, interpreting the data, conclusions drawn based on the organization, and then presentation. Like that it goes. Okay, like tiger example, you identified the area, collected the data like grass area, population of deer, population of monkeys, and then number of lakes present in that particular area, and then you started analyzing. Okay, and when it comes to distribution of industries, you identified the place there, what is the human power, roads, electricity, basic communities, rules and regulations of the land, okay, all these things, and of course weather, etc., etc. Like that. Here electron distribution, available number of available energy levels, Pauli's exclusion principle, all those things are considered while distributing the electrons. So statistics is making use of all possible factors. Okay. Now coming to descriptive and inferential statistics. What is this descriptive statistics? Descriptive statistics is nothing but collection of data, organizing the data, and then presenting the data in the form of tables, charts, bar graphs, or numbers. And then in descriptive statistics, we describe the event. And we give visual effect of the event. You didn't follow? I give you an example. Let us say in your school, not in your school, you are in college, okay, in a school, let us say there are 5,000 students, okay. I want 100 students data. So I have 100 students with me. Let us say 9th standard students, 100 students data is there with me. Well, I will do one thing. I will make charts. How many students have scored 40%? How many students have 20%? How many students have scored 80%? 20% means fail. This is just pass. 80% means distinction. Okay, how many students have scored 70 or 60%? That is first class. This I want to do. So what I will do? I take 100 students data and then count. Okay, let us say 20 students have scored 80%. So distinction 20 students. 20 students of 100 means 20%. Like that I will make the chart. So I will get the distribution of marks. Then what I will do, either I go for column graph, means bar chart, or pie chart. Bar chart means it is something like this column, right? Something like this. Well, this is say first class, that is I call it as F grade. This I call as just pass, P grade. This I call as fail. Okay, I call it as FIL. Okay, this is distinction, so D grade, right? So this is the bar chart. By looking at this, you can easily make out that very few students have scored above 80%, majority of the students have scored above 70, up to 70%, and considerable amount of students have failed in the exam, like that. That is 9th standard, 100 students data. Or I can put it in the pie chart form also. Okay, so this is distinction, this is fail. Okay, this is fail. Well, I write it as FAIL. Well, this is just pass, and the remaining, this is say first class. This is first class. Okay, distinction, only 4 categories, 1 2 3 4, 1 2 3 4. So distinction very less, from this only you can make out. Fail considerable amount, pass okay, but 70% good number of students have scored. This way you are going to describe your data. That is called descriptive statistics, and it is clearly visible. So you are giving importance to visual effect of the data. So I assigned one work to you: collect 100 students data from the school, 9th standard students, and then analyze their pass or performance in the annual exam. So you did like this. This is descriptive. Okay, suppose if I ask you to analyze the whole college or whole school where total strength is 5,000 students. 5,000 students data you cannot analyze. 5,000, it is huge, right? 5,000 may not be huge, but just think of, compared to 100, 5,000 is very high. So when data is huge, you pick the sample. Okay, maybe 20 students from 9th standard, 30 students from 10th standard, 100 students from 12th standard, like that you pick. This is what is called sampling. So you take the samples from each and every standard or grade, and then you analyze, and based on what you get, you draw a conclusion. Inference. Inference means observation or conclusion. Or you are going to make general statements. Okay, suppose from the sample, if you get same type of data, same observation if you make from the sample, what you can say, oh, in this school there are very less number of distinctions irrespective of 9th standard or 10th standard or 11th standard. Distinction is less. Or pass is okay, first class okay, fail is also considerable. That means in this school distinction is very less, fail is considerable. So this school is not a very good school or very good institution for brilliant students. Like that you are going to draw the conclusion. Inference. Okay, inference means final conclusion, observation. So such a type of statistics is called inferential statistics. So descriptive statistics andre bari describe ಮಾಡೋದಷ್ಟೇನೆ ಅದನ್ನ. Inferential statistics ಅಂದ್ರೆ inference ಅಂದ್ರೆ conclusions ಅನ್ನ ಬರೆಯೋದು. ಇದು ಹಿಂಗೆ, it is like this, it is like this ಅಂತ you are arriving at a solid conclusion. This is called inferential statistics. It is not only in the case of tigers or in case of school marks distribution, you can apply everywhere. For example, in medical field, to analyze the blood pressure or sugar complaints, diabetic patients in Bangalore or in Karnataka or in India, 100% we have to use both descriptive and inferential statistics. So with this much explanation, now I take up the major part of distribution statistics, that is Poisson's distribution. So here comes Poisson's distribution. I just give you some examples. Dear students, I hope you are following. So here explanation is more than board work. That's what you can see. I am not writing too much on the board. So I am talking about this statistics. Statistics is like that. Dear students, you have already applied statistics in your day-to-day life. Without your knowledge itself, you have applied the statistics. While choosing the college, you have applied statistics. While choosing your school, your parents have done the statistics, like this. Okay, now coming to Poisson's distribution. Poisson's distribution is very useful even in physics also. I give one or two examples later on. Before I take up this Poisson's distribution, look at these examples. First example, number of accidents occurring in a particular city in 1 year. Number of accidents occurring in a particular city in 1 year. Second example, number of deaths happening in a flooded area every 1 year. So during rainy season it is a common thing. Okay, so heavy floods will take many lives and push their family into tragedy. So this is nowadays happening very frequently. Number of deaths in 1 year, flooded area, of course. Next, number of disintegration. I should write number everywhere. Simply I am writing like this. Assume that there is number here also. Number of disintegration. Where do you come across with disintegration? In radioactive substance. Number of disintegrations in 1 gram of substance. Understood? Or next example, number of people visiting a particular shopping mall in 1 day. Next example, I shine the light. Assume that light is a stream of tiny particles called photons. Number of photons hitting this particular area. Got it? So you can give many examples. Number of people visiting a particular website, or number of steps you put while walking, or consider hens. Koli. Let us say there are 100 hens in a particular area, hen farm, okay, poultry farm. 100 hens. Every day one hen keep one egg only. It lays one egg. For 100 hens, Obviously they put 100 eggs in one day. So how many eggs are laid in 24 hours, or how many eggs are laid in 1 hour? That is also one example to be considered for this discussion. In fact, there is a beautiful problem on hen laying egg which I will discuss later on. Now coming back to these examples, observe carefully: number of accidents, number of deaths, number of disintegrations, number of people visiting the shopping mall, number of photons hitting the particular area, etc., etc., etc. In all these things, you are counting. You are counting. Count. Please follow carefully. You are counting. Counting what? Some events. Some events. See, in the first example, accident is an event. Next, death is an event. Next, decay is an event. Visiting the shopping mall is an event. Hitting the board is an event. Okay. Laying eggs is an event. Counting events. In interval of either time, see, either time 1 year, 1 day, or mass or volume, or area or space. That means events you are not necessarily counting per year, per minute, per day. ಹಂಗೆ ಆಗಬೇಕಂತ ಏನಿಲ್ಲ. ಈಗ ನಾನು ಹೇಳಿದೆ ಫೋಟಾನ್ಸ್, ಇಷ್ಟು ಏರಿಯಾದಲ್ಲಿ ಎಷ್ಟು ಫೋಟಾನ್ಸ್ ಬಂದು ಬೀಳ್ತಾ ಇದ್ದಾವೆ. ಹೌ ಮೆನಿ ಫೋಟಾನ್ಸ್ ಆರ್ ಹಿಟ್ಟಿಂಗ್ ದಿಸ್ ಏರಿಯಾ. ಸೊ that event is taking place over an interval of space, over an interval of volume, over an interval of time. So you are counting the event in a particular interval of space or time or volume. In this count comes what is called Poisson's distribution. So I have given just the hint for Poisson's distribution. Details of Poisson's distribution I will take up in the next video. So Poisson's distribution is not only limited to accidents measurement or people visiting the shopping mall, it is also applicable very much in physics, that is disintegration, or number of particles hitting the surface, or number of laser photons scattered from the surface, number of molecules distributed in a given area. All these things we can discuss with the help of Poisson's distribution. Dear students, wait for the next video. I will come back. Please share your comments and also forward this link to your friends also. Okay. Thank you very much.